Welcome back, NR426 students. We are moving on with Lesson 1 into Lesson 1C, where we'll be talking about decision-making and conditionals with the if statement, a little bit about error handling, and then after a short demo, we'll be looking at how we can work with text files and even create zip files. Then in a second video, we will do the review and recap. In Python and just about any language, there's a way to do a conditional or decision-making in that language, and that's using an if statement. So if is used for decision-making, and the basic idea is if a criteria is met, then you do something. So this is not a loop, it's more of like a static, evaluate a condition, and then do it or do something else, depending on how the code is set up. So here's a really simple example. So if some feature class is equal to roads, then run the buffer. If it's not equal to roads, else, then print that's not the feature class we want to buffer. So here we have just fictional data, but there are a couple of things to take note of in the way it's set up. So we have our if statement, and you can have multiple conditions. You can have an if and an else. You can also have intermediate conditions with an elif. And then we are evaluating a condition with an expression, and we evaluate that condition with the double equal sign. So unlike setting a variable where we say FC is equal to roads, where we're making FC become equal to roads, here it's like we're asking a question with the double equal sign. Is FC equal to roads? If it is, then we go into whatever is indented and we run those lines of code. And then if this condition is not met, it jumps down to the elif or the else if we have an elif, and that'll do that instead. Another type of compound statement in Python that's really handy for errors and working with errors and finding errors and giving back better error messages is the try except block. And this is one of a few ways that you can work with errors, but the basic idea is that you try to do something, and if something goes wrong in that expression or in that line of code, then you raise what's called an exception. So we're trying to do something and telling it what to do if it can't do that. And then you could have multiple exceptions, and it's just a way to get better error messages back to you. So here's again another really simple example. Try to do a buffer on some data. And if anything doesn't work in this line of code, then we do the except. So this is the instead. If something doesn't work, instead, just print the messages. So when we get into lesson 2, we'll learn a little bit more about ArcPy and get messages and how to run tools, but that's what it's doing. So instead of giving a generic error message, we get to pick and choose the type of error message we get. Try except can actually do a little bit more. We're not going to go that far probably in this class, but just so you know, here's an example. This is from one of those videos in the YouTube playlist by Corey Schaefer. So here we're trying to open a file, and we're setting up a variable called badvar. So the exceptions here are if this file can't be found, or if there's something else going on. So we can raise a specific exception, and this is a Python error, file not found error. So raise an exception as a variable. This is like defining it as a variable, and then we're printing that variable. And so this is just a way to get a standard error printed out a little bit nicer rather than a big block of red text. And then here, if something else goes wrong, if some other generic exception happens, then print that one instead. The try except statement can also have an else component to it and a finally. The finally is just a way to force something to run no matter what. Even if nothing goes wrong, still do the finally. Or if something does go wrong, still run the finally. So it's just a different way to kind of force something to be printed out in this case. Notice the indentation, and that the indentation is important on the if statement as well. But here we have our try, colon, and then anything we want to try to do gets indented. And then all of our except statements and our else statement and our finally are all back at the left margin, but they each end with a colon at the end of the line. So that's really important to note. Same thing for the if. You have your if, you have your colon, you have your indentation. So the indentation and structure is really critical to how those are set up. So let's take a quick look at this in the code. So right now we are going to go into the shell window, and right now we're just going to go into idle and start to run a little bit of simple code so we can see that if statement in action. I'm not going to write a real script with a header and everything. I'm just going to kind of start typing. So the if statement allows us to evaluate that conditional. So if something is true. So let's make a little if statement about the weather and what we might do in certain types of weather. So if the weather equals hot. That might be kind of in our heads what we want to start with. But there are some problems here. One, when we're evaluating a conditional, we need a double equal sign. We also need to define weather. Somewhere we have to state what the weather is. So if you're going to do something like this, you might want to say weather equals, and then you could fill it in with whatever you want. And you could run it multiple times, changing it each time. Okay, so if the weather is hot, colon, hit enter. Now I'm indented. What do I want to do if it's hot? Maybe I just want to print out a message. Let's swim. Okay, if I keep hitting enter, it's going to keep indenting. But if that's the only thing I want to do, if the weather is hot, then I want to actually kick it back out. And let's do a few different scenarios here. Then I could do elif weather equals sunny. Maybe I'm going to print something else. So if it's hot, we'll go swimming. If it's sunny, we'll put on sunscreen. Let's do a couple more. Elif, what if the weather is snowy? Then maybe we want to go swimming. No, not swimming. Then maybe we want to go skiing. What if it's none of those things? So then you would just do else. When you do the else, there's no condition. It's just a catch-all, and everything else that's not what you already mentioned will fall into this category. Print. I don't know what to do, which is what my kids say every day in the summer. I don't know what to do. All right, so that's the basic format for an if statement, but we're missing one key component, and that is, what does weather equal? So if we put in hot at the top, save our script, and then run it, oops. Oh, look, I have invalid syntax. So that when you try to run something, it will check for you. And I forgot my double equal sign. So let's save that again and run it again. Oh, look, I have invalid syntax. I forgot my colon. These are important lessons because you should always proofread your code before you run it. Okay, so we had weather is hot, and it printed out, let's swim. Perfect. What if we had weather is hot? Save it, run it. I don't know what to do. So notice that it's case sensitive in here. So you have to be careful with that. You can force things to be read as all lowercase by doing .lower. We'll look at that in another demo. But this is your basic format for right now. What if we wanted to throw in a little bit of error handling? That's where we could do try. For a try statement, you just do try colon, but then everything you want to try to do has to be indented. So you can highlight it and then hit tab. So try to do all of these things. And then you can raise an exception and tell it what to do if anything goes wrong. So we'll be super specific here. Something went wrong. So if I try to run it right now, it's going to work because everything is all set up properly. So if we make a change to it to break it, like creating weather with a capital W, and then save it and run it, notice what happens now. Something went wrong. So because that variable was not defined, it was not a syntax error, so the syntax checker didn't find it. It didn't get found out until you actually went to run it. Another really great thing you can add into your scripts is user input. So there are a few different ways to do this, and we'll look at other ways later on in the course, but the easiest beginner way to do it is just with the input statement. So right in your code, somewhere near the top, usually, you can do input parentheses. And what this will do is allow you to set a variable, like in this example, allow you to create a variable rather than typing in what the variable is equal to. You said the variable will be equal to whatever the user enters. So here, fname equals input and then a prompt. So the prompt is what is your first name, the second one is what is your last name. And now we have fname and lname that represent whatever the user typed in, and then you can carry on with the rest of your code. We'll take a better look at input when we do the demo. Another common thing that you'll do with GIS data is to work with text files or CSVs. So Python is really great for that because Python can read in text files and CSVs even with built-in functionality. So you can open a text file or a CSV and access all the data in it, grab the data out as variables, and then do something with it, either some calculation or updating or things like that. So in order to read a text file, and the format is the same for text files and CSVs, although CSVs actually have their own module just for working with CSVs. We will look at that in 427 if you're still here at the second half of the semester. But in order to access what's in a text file, you would need to open it first. So you can see right here, you can create a variable that opens a text file in a particular type of mode. So read only, or read write, or append. And then once you open that text file, you have a file object. Just like we can have a string object or a number object, you can have a file object. So you create that variable, and then you can write to the text file or read from the text file. You can do a whole bunch more things too, but these are the basics. And then when you're done, you would want to close it. So here's an example from another textbook, the Programming Python for ArcGIS Pro book, where we're reading in a text file of information about wildfires. So they open the text file as a file, they read in everything with read lines, and then we're getting a little bit advanced here. So we're getting into cursors, which is an ArcPy, insert cursor is an ArcPy thing. So they're reading everything in and then accessing it through the ArcPy system in order to calculate it and then eventually update the table. So they're reading in the whole line. They're using split like we learned in lesson 1B to split what would be each column into its own item and then doing a calculation on it. So why would you want to work with text files? So I mentioned just because text files and CSVs often have a lot of data that we want to work with. But you can also use text files to output information. So if you want to create a log file or a report, you might want to output information by writing to a text file. You can also use it as a place to just kind of dump your data after you've done some calculation. You might need to join tables, and you have tabular data and polygon data, and you need to join them in, so you might need to access that text file. And just for your reference, we have a whole bunch of useful methods here. So the different methods related to working with text files. So file, open's not on the list, but open, file, read and read lines, write and write lines. And those are both ways to either read or write, and it's just a matter of if you're doing one line at a time or multiple. And then anytime you're done with your file, your text file, you want to use close to release the file from memory and release that lock. In addition to text files, you can also work with zip files in Python, and we will spend more time on this in the 427 class, but you should know just the highlights here. There is a module called zip file. Here's a really good sample of most of the things that you might want to do with a zip file, but it allows you to read a zip file and unpack it, or also create a zip file if that's what you need to do. Now it's time for another putting it together demo. So take a look at the demo script for that. The link is in the slides, and also it's just in the YouTube playlist. In this demo, we will be putting everything together from all parts of Lesson 1, A, B, and C, starting with the basics, doing some loops, doing some ifs, and using input. And we'll also take a quick look at working with text files.